This is video help on homework number 2. I'm going to do this really quick, so if I'm going too fast, be sure to pause the video. For problem number 1, it's looking for the maximum efficiency of an engine, and that is defined, well, it's the result of the Carnot cycle, which is 1 minus the temperature of the cold side of an engine divided by the hot side of a heat engine. Going on to problem number 2, it's asking you to figure out how many marbles per second are traveling through this pipe, and you want to use the rate equation for this, number of marbles per unit time. That's going to go over here. Part B is asking for a slightly different rate. It's asking for the amount of mass per unit time. So there you want to multiply by the mass of the marble. So I think you want a conversion factor that says the mass in kilograms divided by marble to cancel the word marble out. So here you have marbles per second. Here you have kilograms per second. That's for part B. Part C and D are asking for the flux, and for those, flux is the rate divided by area. So you're going to take the marbles per unit time here, divide through the cross-sectional area of the pipe that it passes through, and put it here. The units will end up being marbles per unit time per meter square. You want to do the same thing from B down to D. The units will come out in kilograms per meter square times time. Alright, and on the second page, this is one we did in class a little bit. You have a radioactive source in a building. The dimensions of the building are 10, 30, and 50. The general equation for flux, heat flux, is Q heat divided by area times time equal thermal conductivity times delta T divided by X. You're solving for delta T, and so you want to pull the X over there and the K down. And also we cleverly isolated Q over T because that was given in the statement of the problem. We're given also T out, and you're asked to find T in, so whenever you get delta T, you can use that to figure out what Tn is. The thickness of the walls is 0.05 meters, and that's the distance through which the heat flows. Area is the area, or the cross-sectional area, through which the heat flows. It asks us to neglect the effects of heat flowing through the floor, so all we need to do is take 2 times the area of the two ends, plus 2 times the area of the sides, plus the area of the top. So use that total area to figure out what goes in right there, find delta T, and then find temperature of the inside of this concrete chamber. So I guess you'll have to look up, I think it does say concrete in problem 12.2. I'll let you verify that. And in table 12.2, you'll be able to find the thermal conductivity that goes here based on the material quoted in the problem. Number 5, you have a house with a brick wall thickness of 8 centimeters. That's going to be the thickness through which the heat flows. It also gives you the cross-sectional area through which the heat passes, the wall area, is given here. They give you the temperature of the inside of the house and the outside of the house on a cold day. Converting these over to Kelvin gives us a delta T. Brick has a thermal conductivity that can be also found in table 12.2. The general equation for heat flow is this, and it asks you to figure out the heat flow per unit hour, per unit time, and in particular per hour, so we want joules per hour. That means we want to isolate Q over T and solve for it. So in the previous problem you're solving for temperature, but in this problem you're solving for Q over T. Multiply it by the thermal conductivity times the temperature difference times the area divided by X. Make sure that you convert the answer, which will be in joules per second, over into joules per hour before you write the answer down here and submit it online. On the next page, in problem number 6, the general equation for fluid flux is V over AT equals this constant, which is the cross-sectional area of the connecting tube, divided by pi, or 8 pi, times the viscosity of the fluid, in this case it's glycerin, times the change in pressure over the length of the tube. They're asking you to find the flow rate in meters cubed per second. That means you want to isolate V over T because that's volume over time. Multiply both sides by area. On just this side over here, V over T gives you area squared divided by this times delta P over X. Be careful about the square pipe that they're mentioning right here. You do not want to use pi r square. Instead, you want to just use the length times width to find the area. That's going to go over here. Make sure you square it. That's a big mistake right there. A common mistake, rather, is you forget to square the area. And so you'll also have meters squared here. So it'll end up being a term which is meters to the 4th power, which looks kind of odd, but the units should cancel out to the point where you get meters squared per second. Make sure you look up the viscosity of glycerin in the textbook and submit it and enter it there and include the units given in that table. Difference in pressure can be found by looking at the statement of the problem. There's the length of the pipe X. On the back page, you want to look in chapter 13 to look at the examples or look at your class notes for this one.